Section 3.7 is about determinants. Now, the title of this section in your textbook is something different, and it deals with a lot of stuff that we're not really going to deal with. We're only going to focus in on the determinants, so I've decided to rename it Determinants. So every square matrix has something called a determinant, and this is a value, it's a number. And we're going to use it in the next section to find the inverse of a matrix, which we will use to solve a system of equations, which is actually a really cool thing to do. A second order determinant is the determinant of a 2 by 2 matrix. And here's some of the notation. So we write DET out in front of the matrix, and that refers to not the matrix, but the determinant of the matrix, which is a number. But we can write it shorter this way by writing the elements in the matrix and using bars. Notice they're not the square brackets. They almost look like absolute value bars, but they don't mean absolute value. And to evaluate that to come up with one number, we do A times D minus B times C. Looks a lot like cross products. A times D minus B times C is the value of the determinant of a 2 by 2 matrix. So let's take a look at an example here. Here we have not matrix 7, 5, 9, negative 4, but the determinant of that matrix. To do that, I'm going to multiply A times D, so 7 times negative 4, and subtract from that B times C. B times C. 5 times 9, which is going to give me negative 28 minus 45, or a negative 73. And that is the value of this determinant. Okay? A third order determinant is the determinant of a 3 by 3 matrix, and there are two ways to evaluate these. The first one we're going to take a look at is called expansion by minors, and this is not in your textbook, but it's very important that you learn how to evaluate a third order determinant using expansion by minors, because this will come up in other math courses. The minor of an element, and remember an element is any one of these terms in the matrix, the minor of the element is the determinant that is formed when the row and column containing that element are deleted. So here we have a determinant of a 3 by 3 matrix. Okay, the minor of A, that is this first element right here, is this right here. And notice if I delete the row that A is in and the column that A is in, I'm left with EFHI. So the minor of A is the determinant of those remaining elements. And then when you evaluate it, you would do E times I minus F times H. So I don't know that you actually can call it a formula, but this is the way a third order determinant works. So if I have this determinant here with letters A through I have A, which is the first term, times this 2 by 2 second order determinant, and notice I got that by getting rid of row A and column A, and I'm left with EFHI. So A times that determinant minus, the second one's always a minus, B times this determinant, which I got by eliminating the row that B is in and the column that B is in, and what was left was DFGI. So minus B times that determinant, plus C times this determinant, which I got by eliminating the row that C is in, the column that C is in, and I'm left with DEGH. So plus C times the value of this determinant. And notice that the signs are positive for A, negative for B, and positive for C. So let's take an example. Take a look at an example. Let's evaluate this 3 by 3 or third order determinant using expansion by minors. Okay, so to do that, I'm going to start with 2, and I'm going to write a 2 by 2 determinant. Okay, and that's going to be the numbers that are left when I eliminate the row that contains 2 and the column that contains 2. So that's going to be 5, negative 4, 9, and 0. So 2 times what remains after I get rid of the rest of that. Now, remember my next term is subtracted, and my value is 7, and I'm going to need a 2 by 2 determinant here, so I'm going to get rid of the row that contains 7 and the column that contains 7 and write the remaining elements. -1, -4, 6, and 0. And that's a determinant. Now my third term is going to be a -3, or plus, remember it's plus, a -3. And now I need to ignore the row that -3 is in, the column that -3 is in, and write those 4 remaining numbers. So -1, 5, 6, and 9. And that may be the most complicated part of doing this. So this is going to give me 2 times, now I need to evaluate this 2 by 2 determinant by multiplying these two and subtracting it by the product of these two. So that's going to be 0 minus a -36. Okay, so 0 times 5 minus -4 times 9, minus 7 times -1 times 0, which is 0, minus -4 times 6, minus a -24. And here, instead of writing plus a -3, I'm just going to do a -3. And then the determinant of this is going to be -1 times 9, which is -9, minus 5 times 6, which is 30. So this is going to give me 2 times 36 minus 7 times 24 minus 3 times -39, or 72. Oops, sorry about that. 72 minus 168 plus 117 for a final answer of 21. So the value of this third order determinant is 21. The second way to evaluate a third order determinant is to use diagonals, and this is in your textbook. So the first thing we need to do is rewrite the first two columns to the right of the determinant. So I'm going to take these first two columns and write them over here. And notice I'm trying to keep my spacing kind of about the same. Then we're going to draw diagonals from the top row down to the right. I'll do this in a different color so it kind of doesn't overwrite them. So I'm going to go draw a diagonal here, and that's going to give me, shoot, sorry about that. I don't know why it does that. It's going to give me A times E times I, and now I draw a diagonal this way, and that's going to give me B times F times G, and now I draw a diagonal this way, and that's going to give me C times D times H. And all of those are actually added, so I can actually put plus signs between them. Okay? Now I'm going to draw diagonals from the bottom row of my original determinant up to the right. I'll go ahead and do these in a different color. So I'm going to go this way, and that's going to give me G times E times C, and H times F times A. Oops, running out of room here. And I times D times B. And those all get subtracted, including the first one. Okay? So to get my final answer, it's going to be A times E times I plus B, F, G plus C, D, H. So those are the ones I got across the bottom being added. And then subtract the ones across the top. Minus GEC minus HFA minus IDB. Okay, let's take a look at an example. So let's evaluate this third order determinant using diagonals. Okay, so I can probably draw the lines here and you can still read the numbers. So I'm going to have these right here. So -1 times -2 gives me a +2 times 2 gives me a 4. Oh, I forgot my first step. Sorry about that. Forgot I have to copy the first 2 columns over here. Otherwise, I won't have enough numbers to do it. And then 3, -2, and -5. Okay, there we go. Forgot the first step. Now, multiply these guys going this way. So 3 times -1 times 0, that's kind of nice. That gives me a 0. And then multiply these here. That's going to give me a -12 times 5 gives me 60. And those are all going to be added. Now I do the same thing, but from my original bottom row, and I go up this way. And since that has a 0, that's going to give me a 0. And -5 times -1 times -1 is going to give me a -5. So I have to subtract a -5. And then 2 times 4 times 3, I will subtract 24. So my final answer is going to be 4 plus 0 plus 60, and then subtract the ones on top, -0 minus a -5 minus 24. I'll go ahead and make that a plus. And that is going to give me a final answer of 45 for the value of that third order determinant. So in this section we took a look at how to evaluate second order, that is 2 by 2, and third order, that is 3 by 3, determinants, and using 2 different methods for evaluating third order determinants, both expansion by minors and using diagonals, and you'll need to be able to do both of those, and in the classwork I've designated which method you need to use on which problems.